This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and today we are talking about leaderboards and especially about time series leaderboards, leakage, and tricks in the leaderboards, and why an alternative is coming from Paderborn. My guest is Marcel Meyer. Marcel, welcome to the podcast.
Hello, Robert. Yeah, thanks for the introduction.
Before we get started, please introduce yourself briefly to the listeners, Marcel.
My name is Marcel Meyer, and I'm a researcher in the data analytics group at Paderborn University. And so the data analytics group is led by Professor Oliver Müller, and we are a group which operates more or less at the intersection of information systems and applied AI.
So you guys are engineers, or you guys are machine learning guys?
Well, we are coming from the information system. So it's intersection, I would say, between computer science and also economics, actually.
Can you share at the beginning, why do we actually need leaderboards when it comes to machine learning AI models? We know leaderboards maybe from the LLM arena and stuff like that, but why do we need leaderboards also for other models? Why is it so important in the research area?
Yeah, I don't know if we really need leaderboards with a ranking, but at least we need a benchmarks, I would say. So we need benchmarks where we measure the performances of models. So we know actually which architectures and which, training approaches maybe work well. And if these new approaches are actually better than older approaches, like also statistical baselines also, especially when it comes to forecasting. Yeah, so I would say we need benchmarks with also different metrics, so to analyze the performance.
Okay, and you have launched now a new leaderboard for time series foundation models. It is called TS Arena. Sounds like a bit for me like LLM Arena, but you can clear that. Why are time series interesting, and why do we need a new leaderboard? Because we already have leaderboards like Gift Eval or FEFbench.
Yeah, so it's correct. Of course, we're inspired by the LM Arena and also other live benchmarks in other domains. Yes, so we have already a couple of benchmarks in that area, but we are also having an issue here in the area, and that is information leakage. That's where we're coming from and why we...
What does that mean, information leakage?
Information leakage, we can go into detail. Basic thing is that you have maybe a test data set where you want to measure the performance of a model, and this data set needs to be separated from the training data set. So you have some training data sets, and you're not allowed to have any overlaps between those different data sets. So you really measure the capability of, in our case, now forecasting, and not the capability of memorizing already known data.
Exactly. So is it a common problem, these, let's call it data contamination or leakage? Is it a common problem when it comes to Gift Eval and FEFbench? And why is it a problem in these leaderboards?
Yeah, so also in other areas, we see, especially for LLMs, for example, we see that we have there some problems with memorization and so on in the leaderboards or in the benchmarks. And here in time series, we have now also this new kind of models, which are the foundation models for time series. And we thought okay, maybe we have here also a similar problem. But actually, so when we speak historically, so I joined the team 2 years ago. And back then, the foundation models for time series were quite new. There were only a couple of them available. And our research goal back then was to simply, for a project, we needed to have a comparison between these new kind of models and transformer models actually trained from scratch. So typically, you have a time series, you train a model on your time series, and then you test on the same time series. You just do a time split, and then you have maybe the last part of the time series for testing, and first part you have for training. And that is the typical approach, how you do it in time series forecasting. And now we have a new paradigm and with these foundation models where you pre-train on a lot of different time series, and then you can use these models with zero-shot forecasting. That means you don't have to retrain the model for your specific time series. You can use them out of the box, more or less.
It's like a ChatGPT for time series, right? So you, instead predicting the next token, you predict the next sensor data point or something like that.
Exactly like that, yeah.
So you had this project, right? And what were your findings in this project when it comes to the leaderboards and to the results of the leaderboards?
Yeah. So for our specific first benchmark, we had selected a couple of test data sets like you would normally do. And after that, we had to analyze, of course, which of these tests, or if any of these test data sets were part of the pre-training data sets of the foundation models back then. And yeah, we thought like, okay, we have now very specific area. So we were talking about household load forecasting. And yeah, when we analyzed then the pre-training data sets of the foundation models, we found it kind of surprising that already a couple of these selected test data sets were part of the pre-training data sets. So we had to exclude them. Otherwise, we would have a train test sample overlap. That means our test data was already part of the pre-training data. So we had to exclude a couple of them. And that was quite surprising for us because we thought like, okay, we are already in a niche, but still there was some overlap. And then also new models came out and we analyzed also the data sets of those models. And we found that it's quite complicated, that everyone uses a different approach in the pre-training data.
But that's okay.
It's okay. And it's totally fine, of course. But then when it comes to benchmarking, maybe a test data set, you have to go through all of the pre-training data sets of all models and check if your test data is part of any of the pre-training data. And that gets quite complicated, actually. So we did a lineage and so maybe model A has pre-training data set A, model B has pre-training data set B, and then model C maybe says like, okay, I want to have massive amount of data, so I just simply model A's pre-training data, model B's pre-training data, and maybe mix in also some new pre-training data. Maybe model A has, it's a good example with the solar data set from the US. Model A says like, okay, I take the whole US for pre-training data with solar. And model B says, okay, I'd only select a subset of that and with a different frequency or so. And then model C mixes it all together. And then in the end, it's really complicated to understand which is now part of any pre-training data.
Do the people of the leaderboards know the problem there, that there's a contamination or that there's a leakage? Because there are also very clever people who are running these leaderboards. But why is there no ambition to solve this problem?
They are aware of that problem. Also, new models are always marking with an asterisk like, okay, we have here actually information leakage. So that is already a big problem in that area, but there's no real solution to it because on the one hand, you want to use your own data. And on the other hand, you have to analyze a lot of different data sets. So it's an open question, I would say, in that area.
But for example, I have a time series foundation model. So is it possible for me as a group or as a lab or as a company to pimp my model for the leaderboards? Is that possible?
I don't know if that happens.
But it's possible.
Maybe if you know like the domains on which the models are tested, maybe you can also pimp the models, but so we didn't train model by ourselves yet.
Yeah.
So no, I don't want to say too much here. I don't think anyone does it on purpose.
Okay. Can you please share what kind of leakage do you see? So you already mentioned the frequency topic. Can you go a little bit more in detail? What does that mean?
Yeah. So basically, when we investigated this whole problem of information leakage and time series foundation models, we found this one type of information leakage where you simply have an overlap between the train and test samples. But also we found another issue, and that is maybe more indirect, more subtle, but with time series, you have, of course, the time component in there. And what we were thinking was like, okay, what if you have now also effects which are then visible in multiple time series? Let's say you have a big crisis or so. Our example is always the COVID crisis and, for example, stock data. So you have one event which influences a lot of different time series. And you see then a certain pattern across all those different time series. And what happens now if you train a model on this pattern and then you take a different time series which has maybe a similar pattern and test it on that? So we did that actually to like understand it and see if it's even a problem. We took like pre-training data, like the foundation models are doing it, and then we mixed in some stock data for model A. We mixed in some stock data from like all over the world until the year 2019. And for model B, we also mixed in some stock data, but including the year 2020 with the COVID crisis. And then we were taking the S&P 500 index, and that was never part of any pre-training data. So we was purely zero-shot forecasting. And then we forecasted the COVID crisis. And the model, which saw already some of the stock data from the year 2020, was significantly better. So there was already kind of information leakage in there. And we have to emphasize that it was only less than 1% of the data was this kind of leakage data. And still, the model was better in predicting the crisis. But it couldn't have known at that time that this crisis will come. So there's a sign of information leakage in there. Well, you have also to take care, like you have correlated time series, and they are not allowed to have a temporal overlap between your train and test time series. Yeah.
So, and now you have your own new leaderboard, TS Arena. Please explain us your approach. How did you set up the leaderboard? What sets you apart? Why might your approach be more reliable when it comes to the other leaderboards?
Yeah, so from our analysis, so we wrote also a paper about it last year. We found 2 requirements which you need to fulfill in order to overcome these challenges. So the one was like, okay, we have this, you need the freedom of choosing your own pre-training data. That's one core requirement for foundation models. And the other requirement is that, you need maybe a global time split across all data sets. So you don't have this temporal overlap between correlated time series. This global time split should be available or should be valid for every data set. And that, when you take that together, it's maybe a conflict between those 2 requirements, because on the one hand, you're saying you can choose any pre-training data that you want. And on the other hand, we have to split also globally in time. So for example, let's say you have to split your data in 2024 and everything after 2024 is our test data. But then you have a conflict in there because you are limiting actually then the pre-training data again. So we thought like, okay, this global time split that must move also with the time. And we can also leverage a unique property of time series data then, because time series data is generated with time. For example, we know that for tomorrow we don't have data yet, but the data will be generated with time. So we can also say that our test data is not existing yet, but it will come. So we know it will come. So we are taking the future as our test data. For that, we developed a forecast pre-registration protocol. And that is, we have like predefined time points where we open a registration window. Within this registration window, you can upload your forecast. And then we close the registration window, and then we simply let the time work for us. So it's simply, we are working until we have our actual test data.
But that's interesting. So you are looking really into the future, right? So these data are not available on the market, right?
Yes. So we are taking live streaming data currently, and then we are saying, okay, tomorrow at 9:00, we are starting a new challenge. You have then tomorrow at 9:00, 15 minutes time to upload your forecast. But we close it because, we are closing the window before the next data point is available. And we are waiting.
And how do you calculate now the wins or lose or the maze or the CRPS of the time series foundation models?
Yeah, so we are constantly working on this project on the TS Arena. We both published it end of last year, the first version, and now we are also extending it. Currently, we only have 2 metrics. We have the maze, and it's for point, so we only have point forecasts right now. but we want to also extend for probabilistic forecast, of course. For point forecast, we have the Maze metric and the ELO ranking. ELO ranking is basically inspired from chess, where you do pairwise comparisons of the models. You're saying they are competing against each other, and so you have a win or lose. So model wins against another model or it loses. And if you win against a very good model, you get more points. If you win against a very basic statistical baseline, let's say, you only get very few points.
Okay. How do you match the results? So there's a tabular, right? And you can say this is place number 1, but you can also compare the models, or am I wrong, to each other?
Yeah, that's basically what we're doing internally. So we are comparing each model's performance against each other. Also, you can drill down in the TS arena for more finer, granular results. You can also go into one specific round from a specific grade and see which model was best on that round. And currently we have this ELO ranking, but we also see disadvantages in this metric because it doesn't measure really the relative advantage. So if a model wins by a big margin or not. So we are also inspired now, like from other benchmarks, like FEFbench, where they have a skill score, for example, and we definitely integrate more metrics. But in the end, we have the ground truth available. We have all forecasts. So it's just some maths, how to calculate now the metric.
Okay. But it's univariate, right? In the moment.
Yes. Currently it's univariate. That means we have simply one time series as input, and we're doing a forecast in that time series. So we have a lot of different time series, but we are not using covariates at the moment. But that's definitely also on our roadmap, because also currently we are only in the energy domain because the data availability is very good there. But also in this domain, it's important to have covariates like weather forecast, for example, which can improve the forecasts. And we definitely want to integrate that also into the future.
So Marcel, what is the aim of your leaderboard? Will we see a foundation model by the University of Paderborn, or what is the aim?
Actually, the aim is to overcome this information leakage in the area, because we saw that it's really a big problem, and maybe also some kind of information leakage that the area was not aware until now. And we want to solve this problem first. We are not planning to develop our own model, our own.
But you have a lot of insights now, how the models perform, what you can do better, because
Yes,
you have all the data, right?
I never want to say no. So, or never say never, I would say. But currently our focus is to extend the leaderboard and to gain insights, which models work well on which data and so on. And that's our first focus.
From your personal perspective, how important are these time series foundation models? What is the big advantages of these models?
Yeah, I mean, especially for the industry, I think they are quite interesting, because now you are able, or more or less everyone is able to do forecasts, because you can use these models really out of the box. You don't need to train them on your time series. You don't need to have a lot of evaluation and so on. Well, we still have to evaluate the performance of these models, of course. Maybe on some areas they are not working as good as in other areas. But in general, what we are seeing is they are better than most statistical baselines. And that's also sometimes really hard, actually. So also like a simple moving average or also seasonal naive forecast is sometimes really good and hard to beat. And they are mostly better than those forecasts. Yeah, so you can really have maybe predictions forecast for your time series data, which was before combined with a lot of work.
Did you already got some feedback from the other leaderboards?
Yeah, actually, we are in exchange with also other people from the area, and we have actually, I think, only positive feedback until now, which is very cool. And but still, of course, we have a lot of things to do still, and we are more or less at the beginning, but we are looking forward.
So can you share what are the 3 main steps you need to walk in the next, let's say, half in a year? What are your goals?
Of course, we want to extend our database, our test.
So everybody can send you a time series to your department?
That would be great. So our requirement is only that we need live data where we don't know the future yet. So really up-to-date data where we can do some information leakage-free forecast. That would be great. Also to get feedback from the industry, like which domains are we missing? I mean, okay, currently we only have the energy domain, but of course we want to integrate then other things, finance, maybe traffic also, and also get like insights. I mean, demand forecasting, so sales forecasting is always a topic in the industry, I guess. I don't know if there are some possibilities to get some data. And then, of course, also from the researchers, if you have a new model, we can integrate it, but also you can participate on your own. So we can send you an API key, and then you can upload your forecast within this registration window. Or also, if you are really a practitioner and want to measure your model's performance against the top foundation models, you can do that as well. And of course, it would be always great.
So if I have a new model, then the model needs to compete against all the other models, right? So there's then a benchmark. I have a battle between Kronos 2 and let's say TEP PFN, or then I have a Tyrex, and then I have a Times FM or something like this. So I have to go through all the battles then against the other models, right?
Yeah. So basically, I don't know, we have currently, I think, around 30 different forecasts, and you are compared against each of the forecasts. So you upload your forecast, and then we are calculating automatically the performance of the model. But also, I mean, that's also one big thing that we want to do, or which is already partly integrated, that if you have, for example, a specific model for load forecasting, for energy load forecasting, then you're maybe better than these general models. And then you get only evaluated on that specific data. And you are also displayed also on that leaderboard for energy, for example. For energy load, you're only displayed there. And then we have maybe more diverse evaluation. For example, when you're now coming from the energy industry and you see, okay, there's a special model for my use case, then I would use rather this model than the general model.
One question at the end, because when I think the guys from FEF published their benchmark, they also measure the speed and not only the performance, the prediction performance, but also the speed of the model. Is it a topic for you too to analyze the speed of the model?
Actually, yes, a very good question. Thank you. Because we are currently running each model within this registration window. And that means you need a very fast inference speed in order to upload your forecast within this registration window. Currently, it all works out because the models are like comparatively small, I would say, compared to LLMs, for example. So we are actually measuring it already. So we are not publishing it yet, but we could do it as well. Because it gets interesting if you have very low frequencies for forecasting, where you need very fast forecast speed. Because, for example, you want to predict the next 60 seconds or so, then you have to deliver your forecast in, I don't know, maybe 10 seconds. Otherwise, you have already the real data when you did your prediction. So it's so it's a very good question. We are measuring it, but not publishing it yet.
Marcel, it was a pleasure. Thank you very much. I keep my fingers crossed for your leaderboards. I think it's a real cool approach, and I hope maybe the other leaderboards will say, okay, that's some great idea from University of Paderborn. We can add this, or we can improve our leaderboards. Thank you very much. It was a pleasure.
Thanks a lot, Robert, for the invitation.